Lesson 8.1 talks about the sine law. So this unit we're going to be talking about tools and strategies that we can use to solve angles and side lengths when we're working with a triangle that does not have a right angle. So the first thing we're going to do in a little investigation is just draw an acute triangle. Don't draw it so big because you want to have some space to do your work, but just any acute triangle. An acute triangle is a triangle in which all of the angles are acute. Doesn't matter what your triangle looks like, as long as it is acute triangle, an acute triangle. And we're going to label our vertices A, B, C. Now in naming our corresponding side lengths, the side length B is always opposite the angle B, and it's represented by a lowercase letter. The side length A, side A, is a lowercase a, and it's going to be across from angle A, and side length C, with a lowercase c, is going to be across from angle C. Alright, now what I would like us to do is to measure side length A, side length B, and side length C. So we should all have different triangles, we'll all have different measurements, but go ahead and do that. Now that we have the measurements of the lengths of three sides, we're going to calculate some ratios. Who remembers what a ratio is?
It's like a number over in comparison to something on a scale factor.
A way of comparing two numbers that have the same units of measure. Good job. So we're going to take a whole bunch of ratios here. We're going to first calculate the ratio A over B. Then we're going to calculate the ratio sine of A over sine of B. Then we're going to take the ratio of A over C. And then we're going to calculate the ratio of sine of angle A over sine of angle B. And we actually missed a step in here because we don't have the sine of A or the sine of B or the sine of A or the sine of C yet. So we need to calculate those yet. So we are also going to use our protractor to get a measurement for angle A, angle B, and angle C. Go ahead and do that now using your protractor. Okay, now that you have your three angles, you're going to use your calculator and you're going to get a value for the sine of A, you're going to get a value for the sine of B, and you're going to get a value for the sine of C. So all you have to do is go on your calculator, hit sine 46, and that will be the value here. Sine of, for me, 80 will be the value here, and for me, sine of 54 will be the value here. Go ahead and do that step. Remember that when we're recording the value of a ratio, we want to leave 4 decimal places so that we are precise and don't lose any information. Okay, now that we have the lengths of our sides, we have the measure of our angles, and we have the sine ratio of our angles, we're going to find some other ratios. We're going to find the comparison, we're going to find a value for A over B, and a value for sine A over sine B. We're going to find a value for A over C, and then sine A over sine C. And we're also going to find the value for B over C, and then the value of the sine of angle B over the sine of angle C. So using the values that you found up in the top, go ahead and find those next ratios. Okay, go ahead and see if you can notice any relationships between these ratios. Any relationships between these ratios? Are there any values that came out pretty much the same? What were they? So what you should have noticed is that the ratio of sides should have came out to be pretty much the same value as the ratio between the sine of those corresponding angles. So I have my 3 boxes showing the relationship there. In a perfect world with a perfect triangle and perfect measuring, they would be exactly the same. Okay, so far we found out that the ratio between 2 sides is equal to the ratio of the sine of their corresponding angles. We're going to go ahead and try to find another set of ratios. and see what we come up with. We're going to calculate each of the following ratios. We're going to put the side length of A over the sine of angle A. We're going to find out what that is. Then we're going to do the same with B and sine B. Find out what that ratio is. And we're going to do the same with C and sine C. Go ahead and use your triangle, your measurements, punch them into your calculator. And I'm going to go ahead and do the same with my numbers, and we'll see if we can draw any conclusions from that. Okay, your calculations probably came out quite a bit different since we have totally different triangles, but when I compare my three values, my ratios, I get 7.65, 7.21, and 7.2. Now again, mine aren't perfect. In a perfect world, my numbers would be almost exactly the same. But mathematically and algebraically, if we could do this perfectly for an acute triangle, we would find that in fact, the ratio of A, the side length of A over the sine of angle A, would be equal to the ratio of side length B over the sine of angle B. And that would be equal also to the ratio between the side length C and the sine of angle C. And this is what we call the sine law. And we can use it to find the length of a missing side when we have another ratio already, or we can use it to find the find the measure of a missing angle when we have other information already. And that's what we're going to be getting into today.
Next page.
Still on that page. Should have lots of space. Sine law. The relationship between the sides and their opposite angles, the relationship between the sides and their opposite angles in any acute triangle we're going to name that triangle ABC. This just stands for any acute triangle, and here is the heart of the sine law right here. A over sine A is equal to B over sine B is equal to C over sine C. So the sine law can be used in two different forms actually. The first form, which we've already written down, is very helpful for finding a missing side length. The second form of the sine law that I've written down is very helpful for finding a missing angle measure. And again, these can only be used in acute triangles. That means triangles that have all of their angles less than 90 degrees, so not a right angle triangle. And the way we get algebraically from our first form with the side length over the angle, sine of the corresponding angle, to the sine of the corresponding angle over the side length is by simple algebra, and I'll just explain briefly without going into detail. But if we considered just these two ratios, because you can only use two at a time, you don't need that third one if you're using two already, all you would have to do is multiply both sides by sine A, and then multiply both sides by sine B. That would end up with sine B up here and sine A up here, and then divide both sides by A, little a, and divide both sides by little b, and you'd end up getting this box right here. And so we can use the sine law either way. If we want to use a side length, we'll put the little letters on top. If we want to find an angle measurement, we'll put our sine of the angle measurement on top. Now in using the sine law, we'll make one more note, just to clarify. So So in this case, let's say we know, well, I'll just write what we have here. We've got little b, so side length b over the sine of b is equal to the side length c over the sine of c. If we were going to use this one, we would likely be using it to find either b or c, the side length, which means we would need to know the angle b, so that we could put sine b in our calculator, and we'd need to know angle c. And then if we know side length c, we have a ratio, we have what I call opposite information in the triangle. We'll explain that a bit more later. Then I can use these pieces of information to find b, simply by multiplying both sides by sine b, and I would get the answer there. In the same way, if I wanted to use the sine law to find a missing angle, I would just need to use two parts of the sine law. I'll never need to use all three parts of the sine law at the same time. You may need to use all three parts in order to solve a triangle, but two parts at a time. So if I wanted to solve for angle B, let's say I was missing angle B, I would need to first make sure I had angle C and side C. If I don't have angle C and side C, I will not be able to use this ratio to find angle B. Then I would probably just check to see if I have the measurement of A over A, and if I have that, I can use that. But let's say I do have the angle measurement of C and the side length of C, and I have the side length of B, then I can use those three pieces of information to find this fourth piece of information. I would multiply both sides by B, and then I would take the inverse sine of what I got, and I'd be left with the measurement of angle B. We're going to go ahead and do a few examples that help us to solidify our understanding of the sine law. Okay, example one. Example one, we're talking about, you see the picture there, you have the canal, lock 1 and lock 2, and there is a path coming off of lock 1 at an angle of 66 degrees. That is a bicycle path that forms a 66-degree angle with one lock of a canal. At a distance of 2.5 kilometers along the bicycle path, the angle separating this lock from the next lock is 52 degrees. How far apart are the two locks to the nearest tenth of a kilometer? And this is an example where the sine law comes in to find the side length. So the first thing we're going to do is draw a simplified diagram. Okay? So we're going to redraw this diagram, and without the picture of the locks in it, and we're going to label what we know. Your diagram does not need to be perfect. It should look kind of how the other one looks, but again, doesn't need to be perfect.
No, it's there already.
We're going to call the first one, first lock L, second lock K, and the point where the path, where we stop on the path after 2.5 kilometers is going to be called point P. Now we also know that angle L is 66 degrees, and we've been told that angle P is 52 degrees. That's the angle separating the two locks. Once we've traveled 2.5 kilometers down the path. Okay, so we have a simplified diagram to work with. Now, in order to find the distance between the two locks, I need to have a completed ratio. So what that means is I'm going to just write our sine law. We've got A over sine of A is equal to B over the sine of B is equal to C over the sine of C. That's the sine law. In order to use the sine law, I have to have at least one part of the sine law complete. I have to have the top and bottom of either the A's, the B's, or the C's. Do I have that in my diagram? I have angle L. Do I have side L? No. I have side K. Do I have angle K? No. I have angle P. Do I have side P? No. So I don't have enough information to use this. Or do I?
Yes. 1.5.
I can find my last angle, can't I? Can I find the measurement of angle K? Okay, before I can use sine law, I must find the measure of angle K. Well, angle K is not difficult to find. What is the sum of interior angles of a triangle? 180. So we're taking 180 degrees. We're going to subtract the measure of angle L and subtract the measure of angle P, and that will give us the measure of angle K. So we've got 180 minus 66 minus 52, and we get that the measure of angle K is 62 degrees. I can add that to my diagram. Now do I have enough information to use the sine law? Yes. I have my K's. So all I need to do is put my side length K, which is 2.5, over the sine of the angle, which is the sine of 62 degrees. And I want to find out the distance between the two locks. So I want to find the side length of side P there, the length of side P. So I'm going to put P above, because my side lengths are the numerator in each of my ratios. And we got the sine of 52 in the denominator. Now what do I need to do? What step in algebra?
Oh. Wait, can you not put sine?
I've got it. Oh, I don't need this third ratio. As a matter of fact, I can only ever use two ratios at a time. Okay?
Multiply both sides by sine 52.
Let's multiply both sides by sine of 52, which is going to give us this. It is going to give us, on the left, we're going to have the sine of 52 times 2.5 over the sine of 62. And that's going to be equal to P. And that we can do in our calculator very carefully. I would do, depending on which calculator you have, you can either do the sine of 52 and then print that answer with a lot of extra decimals and then divide and then multiply, but it's much better if you just do this part first, 2.5 divided by sine of 62, hit enter, and then multiply that answer by the sine of 52. Right? Multiplication is commutative, so we can do it backwards. That's quite all right. You're going to end up with P equaling approximately 2.2.
2.2? I got 0.33053275.
Which tells us, I'll revisit those issues in a second, but we'll just finish the problem here. The distance, finishing with a statement, the distance between the two locks is approximately 2.2 kilometers to the nearest tenth of a kilometer. So again, we drew a simplified diagram labeling all the points and angles that we needed to find. We put in the information that we know, that's all in blue, and in pink is the information that we wanted to find, but we didn't have enough information to use our sine law. We first had to complete one of these ratios by finding our third angle, and then we could use that and some simple algebra down here in pink to find the distance P from lock 1 to lock 2. Here comes example 2. We are again in an acute triangle. This time we're in triangle TUV, and we have some information, but we don't yet have a diagram. So the first thing that we want to do is to draw a diagram. So use the information that's in the problem and do your best to draw a diagram of that triangle TUV, and check up here in a second to see how you did. So in drawing a diagram, whatever you label it, that's what it is. So your distances don't need to be exact. But what I would do is start with angle T. Start with angle T and make it look like it's about 31 degrees, because we're told that angle T is 31 degrees. Now, the leg coming off of T toward U is 11 centimeters. And that's much longer than the other leg, so I just want to make sure that I give myself enough space here. Let's call that 11.1 centimeters. And it means we'll call this corner, this vertex, U. And UV is 5 centimeters. UV is 5 centimeters. So I've actually done that a bit long, or my angle's not great. But either way, I'm going to bring that into there. Angle U, angle V. UV is 5.8 centimeters. Again, your diagram does not need to be perfect. Does not need to be exact. And this one actually really isn't that great at all. But we're going to try to find the measure of angle V using our sine law. Now this time, because I'm trying to find the measure of angle V, I'm going to flip my sine law. So this time I'm going to look at it this way. Instead of having the length of the side on the top in the numerator of my ratios, I'm going to have the angle on the top. And applying it to this problem, we're going to have the sine of t over the length of side t is equal to the sine of the measure of angle u over the length of side u. And that's going to be equal to the ratio of the sine of angle v over the length of side v. So we can use our sine law either way. This time, because we're trying to find an angle, I'll use it with the angle measurement on top. So right away we can just apply our sine law by plugging in our information. Do we have opposite information in the triangle? Yeah, we have angle t and the side length of t. So right away I know that I can use sine law without any extra work. Sine of 31 over 5.8 is equal to, am I going to worry too much about the u ratio here? I don't need it. I'm looking for v. So I'm just going to go ahead and use the sine of v, which I don't know yet, over 11.1. And you can see the algebra coming up here is just multiply both sides by 11.1, which is why we put our unknown variable in the numerator, right? That makes it easier. So that's why we use this version of the sine law rather than the other version. Again, multiply both sides by 11.1. You end up with the sine, and I'm flipping it here, putting my sine on this side, equals 11.1 times the sine of 31 over 5.8. If you put that in your calculator, you will get that the sine of v equals 0.9856, and the decimals go on for a long time. Keep that answer saved in your calculator. So that means if you calculated it, just leave it alone now. Don't hit C or on or off or anything, because now all you have to hit to find out what the measure of angle V is, we're taking the inverse sine of both sides, and all you have to do is hit the inverse sine second function answer. And it will give you an approximate, well, it will give you an exact measurement, but we'll round it to the nearest degree, which gives an angle measurement of 80 degrees for angle V. If your calculator can't do this and store it, that's fine. Just make sure that you use at least 4 decimal places in your ratio when you take the inverse sine. Okay, so you would take the inverse sine of 0.9856763,158. You don't need that many decimal places, but you typically need 4 or more to get an accurate answer. So the measure of angle, the measure of angle V is about 80 degrees. In example 3, we're looking at the Bermuda Triangle. It says, use the information given on the diagram to determine the perimeter of the Bermuda Triangle to the nearest 100 kilometers. What does the word perimeter mean?
Outside.
Yeah, around. So we're essentially adding the length of each of the 3 sides together. Okay, we're going to draw first a simplified diagram. We'll label our points. We'll call them M, B, and S. We're given that angle M is 50 degrees. We're given that angle S is 74 degrees. We're given that the length MS is 1,000 kilometers. So here's, 1,600 kilometers. I misread
It's
that.
1,000.
Nope, 1,600.
1600.
Yeah, 300.
No, I can.
Good. Now, in order to find the perimeter, I want to find the length of MB, the length of BS, and the length of MS. I already have MS, so I just need to use my sine law to get MB and BS, but I have a problem here. I don't have any what I call opposite information. What should I do?
Interior angle.
Label a B.
Interior angle.
I'm going to first find the measure of angle B, which is 180 minus 50 minus 74. So the measure of angle B is 56 degrees. Add it to my diagram. Now I have enough information to use my sine law. I'm looking for side lengths. So I'm going to put the side lengths on top. We've got M over sine M, B, lowercase b, over sine B, and S over sine S. Now I have B over B, so I'm going to use that in both cases as my starting ratio. So I've got the side length of B, 1,600, over the sine of B, which is the sine of 56. And first we'll find MB. Now be careful, we should label our sides. The side length MB has another name, side length S. The side length BS has another name, side length M. Good job. So here we have the side length S over the sine of 74 degrees. That means S is going to be equal to, multiply both sides by 74, sine of 74 times 1,600 over the sine of 56. And that's going to get us a side length for S of approximately 1,855. The process for finding the side length of M is exactly the same. We're going to start with our same ratio, 1,600 over the sine of 56, and set it equal to, this time looking for M, so side length M over the sine of angle M, which is given to us as 50 degrees. Multiply both sides by the sine of 50. We're going to end up with M equals the sine of 50 times 1,600 over the sine of 56. Carefully punch that into our calculator, and we end up with a side length of M of approximately 1,478. Now the perimeter of the Bermuda Triangle is just the side lengths, the sum of the side lengths, so M plus S plus B. And we can sub in the values that we know. We were given that B is 1,600. We found that M is 1,478, S is 1,855, and B 1,600. If we chuck those into our calculator, we get 4,933 kilometers. We look back at our question. We were asked to find the perimeter of the Bermuda Triangle to the nearest 100 kilometers. To the nearest 100 kilometers. So here's the one I'm needing to find out, I'm going to round to there, which means I need to look at this digit, the one just to the right of it. If it's 5 or higher, I'm going to round up. If it's 4 or lower, I'm going to round down. Am I rounding up or down? Down. Okay? So, the perimeter of the Bermuda Triangle is about 4,900 kilometers. 4,900 kilometers. Again, running through the steps, we needed opposite information, so we needed to find angle B. We simply used the sum of interior angles of a triangle to find angle B. Then we had enough information to use sine law. I put the side lengths on top of the ratios because I'm finding perimeter, which deals with side lengths. Used the ratio 16 over sine 56 twice. Once to find the side length of S, then once to find the side length of M, then found the perimeter by adding up our side lengths, rounding to the nearest 100 kilometers.